Welcome back. So here I have brought the part 2 of the 2019 January Unit 1 physics paper. So this is part 2 starting from question number 15. P and Q are the identical spheres. Sphere P moves along a smooth horizontal surface and collides with sphere Q, which is initially stationary. After the collision, sphere P moves off with a momentum of 0.096 kilogram meters per second in a direction of 15 degrees to its initial sphere. Sphere P moves off with a momentum of 0.14 kilogram meters per second in a direction of 10 degrees as shown. Okay, before collision, after collision. So part A says, use a scaled vector diagram to show that the magnitude of the total momentum of spheres P and Q after the collision is about 0.2 kilogram meters per second. Okay, now here I have attached the marking scheme. So they have told us to draw a scaled vector diagram. So the construction of correct vector diagram, parallelogram or a triangle with all three directions and 0.096 and 0.14 labeled gives 1 mark. Momenta correctly scaled gives us 1 mark. Horizontal resultant to within a slope of 1 small square gives us 1 mark, and total momentum equals 0.22 or 0.24 gives us 1 mark. So this is how we draw it. Okay. Then part B. State the principle of conservation of linear momentum. So total momentum before collision is equal to total momentum after collision. Then part C. Calculate the initial velocity of sphere P. Mass of sphere is P as given 0.12 kilograms. So the equation for momentum is mass into velocity. So we know we can take the momentum from here. So 0.24 kg ms minus 1 equals 0.12 multiplied by velocity. So we subject velocity and we get 2 ms minus 1 as the initial velocity. Then question number 16. In 2016, the European Space Agency sent the Schiaparelli probe to Mars. As the probe approached the surface of Mars with a vertical velocity component of 460 meters per second, a parachute was opened to reduce the speed of the probe. Once the vertical velocity of the probe had reduced to 75 ms-1, the parachute was removed and the thrusters were switched on. Due to an error, the thrusters were switched off too soon, leaving the probe to free fall to the surface of Mars. So this is what happened. The parachute opened at 460 meters per second, and then the parachute removed and thrusters switched on. Then it's 75 meters per second, and then the thrusters switched off. Then it's 68 meters per second, and then once it falls in a velocity of 150 meters per second. So part A, the parachute was used over a decrease in height of 9.7 kilometers. Roman numeral 1 show that the average vertical deceleration of the probe due to the parachute was about 11 ms minus 2. So we use the equation v squared equals u squared plus 2as. We know the final velocity, it's 75 ms minus 1. Squared equals, initial was 460 squared plus 2 into acceleration we don't know plus 9.7 into 10 to the power 3. That's the height, the distance. It's 10 to the power 3 because we convert kilometers to meters. Then once we subject acceleration, the answer is minus 10.6 ms minus 2 since it's deceleration. Then Roman numeral 2. The parachute was at an angle to the vertical as shown. The total resistive force acting on the parachute and the probe was at an average angle of 6 degrees to the vertical. Calculate the magnitude of the average total resistive force. You may neglect the mass of the parachute. Mass of probe equals 600 kilograms. Gravitational field strength on Mars equals 3.8 newtons per kilogram. So then 600 kilograms we multiply by 3.8 newtons per kilogram. Then we minus it by F cos 6. Okay, because there is an angle as well, and it is cos because it's vertical. The component is vertical. Then we multiply it by the acceleration, the deceleration we found in the earlier question, which is minus 10.6 meters per second, then the answer is, we need to get the force. So then the answer is 8690 newtons. Okay. Okay. Then part B. The probe was in free fall from a height of 3.7 kilometers, reaching the surface of Mars with a velocity of 150 meters per second. Explain whether the term free fall is correct in this context. Your answer should include a calculation, and they have given us the gravitational field strength on Mars. So, free fall. So when it comes to free fall means gravity is the only force acting on the probe, and there will be also drag or resistive force acting on the probe. That means the forces acted by air on the falling object, since it's free fall. So we need to find whether we can say it's free fall. So they have given us the height and the velocity. So we use v squared equals u squared plus 2as, and we need to find what is v squared. So we put 0 as initial acceleration, and then we multiply 2 by 3.8 meters per second, multiplied by 3700 meters, and then v squared is 28,120. Then we divide v square. Now since it's squared, we find the square root, which is 168 meters per second. So 168 meters per second is the actual free fall value, and it is bigger than 150, which was given, which is actually when we calculated the free fall value is 168, but then they have given us it's 150, and they are asking whether the velocity is 150 meters per second, and they are asking is it falling in free fall, but it is not, because the value is smaller. Therefore free fall is not the correct term to use. Question number 17. When concrete is first made, it has a high moisture content. As the concrete dries, its properties change. The manufacturer of concrete carried out compression testing of cylindrical samples of concrete using the equipment shown. The diagram shows stress-strain graphs up to the fracture point for concrete samples 2 days and 28 days after being made. A. As the concrete dries, its Young modulus increases. Show that the value for the Young modulus of the concrete after it has dried is at least 1.3 times greater. So Young modulus 28. Young modulus is stress divided by strain. So we take stress 140 into 10 to the power 6. Then we divide by 0.0032. Okay. And then for 2 days, it's 104 into 10 to the power 6 pascals divided by 0.032 equals 0.25 into 10 to the power 10 pascals. So then we divide 28 days Young modulus by 2 days Young modulus, and we get 1.35. Then part B. The energy absorbed before fracture by the 28-day-old sample is less than the energy absorbed before fracture by the 2-day-old sample. The area under a stress-strain graph gives the energy absorbed per unit volume of the sample. The energy absorbed before fracture by the 2-day-old sample is 0.35 megajoules per meter cube. Determine the percentage reduction in the energy absorbed before fracture between the 2-day-old and the 28-day-old samples. You may assume that the volumes of the cylindrical samples are same. So before fracture. Okay. So for E28, it's half into 80 into 10 to the power 6 pascals. It's 80 because now they're asking before the fraction. So because of that, it's 80. Okay. And then we multiply it by 0.019, then plus half into 80 plus 12, 128 pascals into 10 to the power 6 into 0.0038 minus 0.0019. plus 64 into 0.0001 into 4 into 10 to the power 6 pascals. And when we get 299,200 joules per meter cube. Then the percentage reduction equals 350,000 joules per meter cube minus 299,200 joules per meter cube divided by 350,000 joules per meter cube, and then we get the answer, and then we multiply by the answer by 100 because they are asking about percentage. So then the answer is 14.5%. Okay. Then part C, manufacturers recommend leaving concrete blocks to dry for at least 28 days before use. Discuss why. So we know once we like when we make something we using concrete, at first once it made, it's like kind of moisturized, okay, it's not dried, and then it can easily break. But when time pass by, it slowly dries and then it's strong. So they're asking why manufacturers do that. The concrete, when concrete is made, it's less tough. Once it's made, the concrete is less tough when it's made, so the break-in stress is greater. So we need to leave it to become stiffer, or else a change in the properties of the concrete after you have used it could cause problems. Question number 18. A luge is an event at the Winter Olympics. An athlete flies on a small sledge and races down an icy track feet first. Part A. An athlete accelerates down a straight section of the track as shown. The track is at an angle theta to the horizontal. Draw a free body force diagram for the sledge and athlete. You should consider the relative sizes of the forces when drawing your diagram. So this is the diagram. Weight is there, normal contact force. So you must make sure that friction should be smaller than normal contact force. Okay, because at the starting point, friction is smaller. Okay. So because drag force is larger since it's a slope. Therefore friction, the force arrow should be shorter compared to others. Okay. Then, part B. The mass of the athlete is one of the factors that affects her time to complete the race. Roman numeral 1. Explain why the mass of the athlete has little effect on the initial acceleration. Initially, friction is less. Okay, so mg sine theta equals to mg. So the masses on both sides cancel. Therefore, it has little effect. Roman numeral 2. Explain in terms of forces why the athlete reaches a maximum velocity. So maximum, they are asking why the athlete, maximum here means constant velocity, like terminal velocity which we used to learn in O level. So here maximum means that. As the athlete's velocity increases when he is moving down the slope, air resistance also increases. At one point, friction becomes equal to the weight force. So then resultant force becomes zero. Therefore, no acceleration. Okay. Roman numeral 3. It is stated that the maximum speed is greater for athletes of greater mass. Suggest why this is only correct up to a certain mass. A larger person will have a larger area. So the air resistance acting on the person will also be greater. That means higher the area, more air forces can act on the whole body. Okay. Then part C. After the finish line, there is a straight uphill section of track for the sledge to decelerate in. The maximum permitted gradient of this section is 20%. Roman numeral 1 show that a track with a gradient of 20% is at an angle to the horizontal about 11 degrees. So now they have given this diagram from this one, from this diagram which they have given in part A. So now in this part A, you can mark the opposite side, the adjacent side, and the hypotenuse. So here we can see the hypotenuse is not there. Therefore, only the opposite side and the adjacent side remain. So it's tan. So then we take inverse tan in the calculator, and we it's 20% they have given. So we take it as 0.2%. Then we get 11.3. Roman numeral 2. An athlete reaches the finish line at a velocity of 33 meters per second. Then she applies a minimum braking force of 240 newtons as she moves along the uphill section of track to help her come to a stop. Calculate the minimum uphill length of track L that should be available for braking. You should ignore all frictional forces other than those applied by the athlete. Mass of sledge and athlete equals 95 kilograms. So here they are asking us to calculate the minimum uphill length. Okay, so the athlete is moving. So the energy we should consider is kinetic energy. So the equation for kinetic energy is half into mass into velocity. Okay, so then the answer is 51,728 when we multiply half into 95 into 33. So then um, we must take the gravitational field strength and the um, weight as well. Okay, the work done as well. So because kinetic energy equals to that, because we must take all the forces, because all the forces helps the athlete to move. Okay, because there they have tell you should ignore all frictional forces, but they have told us to consider the forces applied by the athlete. Okay, so therefore, we found for kinetic energy, and then now that's the total. Kinetic energy is the total force here. Okay, so then 51,728 joules equals 95 plus 9.81 into sine 11.3. Okay, plus length we don't know, and then we must again add it to 240 newtons into length. Okay, because here we have taken the horizontal and the vertical components like mentioned in here. Okay, then once we subject L, the answer is 122 meters. So the final answer is 122 meters. So this is the end of the paper. So please subscribe, like, comment, and share my videos with other study mates of yours, and also do comment. And also maybe I have made some mistakes and during my pronunciations as well. So I'm really sorry because I'm new. And then please do comment positively, and you can point out my mistakes in a positive way so that you don't hurt my feelings, and also you inspire me at the same time to upload more videos. So bye for now, and let's meet from another video. Stay safe, study well. Bye.